adiabatic temperature changes. Adiabatic is just a big word to say that no heat is actually transferred. You may think it is, but it's not actually. So these are great examples. Right? If you put air in your tire, right? Your car tire, your bike tire, whatever. They like bike tire because you usually hold it as you're doing it, right? So you put air in your bike tire, you're pumping, you're pumping, you're pumping. You can feel that tire heating up. But that's not what's actually happening. What's happening is the air is being compressed, right? As it goes through that pump, it gets squeezed into that little bike tire. And then it warms up, right? It appears that the air is warming, and the air is warming, but no heat is being transferred to it. Now, it's the exact opposite when air expands. When air expands, it feels like it's cooling down. And then when you clean your keyboard, right? People still do this because people still have keyboards, so far I can still use this example. But when you clean your keyboard, you have that little can with the super straw nozzle. You put in there, and then you go right, and this air just blows everything off of your keyboard. And if you do it for too long, that can gets cold. I mean, you can even start to see ice crystals on the side of it if you do it for too long. And so that's the compressed air expanding out, and so it cools. No heat is actually transferred to cause the warming or the cooling. So that's why it's called adiabatic. Now this happens in the air too. Okay? As the air moves up, it expands and therefore it cools. Unsaturated air, which we don't have in Florida, but unsaturated air cools at a rate of 10 degrees Celsius per 1,000 meters. That's called the dry adiabatic rate. So dry adiabatic rate, unsaturated air moving up, expanding and cooling. Now what happens when things expand and cool? Condensation. Because it reaches its saturation, it's still cooling, so therefore it becomes oversaturated, and condensation happens. At this point in the air, it's called the lifting condensation level, and I'll show you that in a second. So air goes up. Now, we don't have a dry adiabatic rate, right? We would have a wet adiabatic rate, a saturated air adiabatic rate, and that is 5 degrees Celsius per 1,000 meters. Here's what I mean by the lifting condensation level. So the air above the bay rises, it cools, it cools, it cools, it expands, it cools, it expands, it cools. It reaches saturation, it can no longer hold the water that it has, so it starts to form your cloud. And you'll notice your clouds actually have a flat bottom, because that flat bottom is the lifting condensation level. So it continues to go up, you continue to cool, you continue to expand, you continue to condense out.